Hi, my name is Emma Magnuski, and this is a video explanation of Problem 2 in Section 1.2 of Sibylla Beckman's textbook. It is part of a video assignment for my mathematics for teacher courses at Bridgewater State University. Today I'll be describing decimals in terms of bundles to explain decimals a little easier. Here we have the decimal point 0.26. The 2 in this decimal point represents the tenths. And the 6 will represent the hundredths. So the first decimal point is, the first number after the decimal point is always the tenths, the second is the hundredths, and it goes on from there to be the thousandths, millionths, stuff like that. So I'll be describing the tenths in terms of bundles of 10. Because when we think of a tenth, then the word 10 is in it. So we'll be doing 2 bundles of 10 to represent 2 tenths. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 bundle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 bundles. This is 2 bundles of 10. Now inside of each of these is a hundredth. So 10 of the hundredths make up a tenth. So that's why we can have 2 tenths. So if we had 4 more of these, this would make it 3 tenths. So using that logic of one of these being a hundredth, going into the total of a tenth, we can write 6 lines, 1, 2, 3, 4, 5, 6, considering this is only 6 parts of a bundle. This is 6. So the 2 tenths with 6 hundredths would get you the decimal point of 0.26 or 26 hundredths. So if we counted all these out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, we would get to number 26. And altogether, this would be 26 hundredths. 26 hundredths. All right? So using our knowledge about the tenths, we go on to 13.4. So 13 is a whole number. And we know that this is the tens place, and this is the ones place. And by identifying this as the tenths place earlier, we know that the 4 is part of the tenths place. Now, 4, so if we had 0.4, if we added 0.6 to this, we would get a 1. If we add another 0.4 and then another 0.6, we would get 2. So these 10 of these equal the ones place. So using that, if we knew that we needed to get 13.4, we could do 10 bundles. So 13 bundles of 10. So we could represent that in bags. So 1 bag equals 10 bundles of 10, right? So let me get my eraser, one moment. I'm just going to erase all the stuff up here. Sorry about that. So if we have 10 bundles of 10, right? So in order to get 13, we would have to write out is equals a 1. We'd have to write out 13 bags. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now we have 13 bags, which equals the number 13, because there are 10 bundles of 10. Erase this part. Okay. So now we have 10 bundles of 10, 13 times, which we did get the 13, but now we need the 4/10. So because we know each bag is made up of bundles of 10, and we know that a bundle of 10 equals a tenth, we can write out 4 bundles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we have 13 bags, which represents the whole number 13. And we have 4 bundles of 10, which equals the 4/10. Now, if we move on to a simpler number, like 1.28. So we know that this is the ones place, and this is the tenths place, and this is the hundredths place. And we know, using what we just learned, that if we do 1 bag, it equals 10 bundles of 10. So that would be 10 bundles 10, which is 10 bundles of the tenths place, essentially. So for the number 1, we would have 1 bag with 10 bundles in it. And for the tenths place, we know that if we write out 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1 bundle of 10 and 2 of the tenths bundles. And now for the 8th hundredths, it'd be like what we did up there for the 0.26. So now we just write out 1, 2, 3, 4, 5, 6, 7, 8. So this is 1.28 or 1 and 28 hundredths. So this is the ones, the tenths, and the hundredths. Using our knowledge of 1 bag equal 10 bundles of 10, which are the tenths, goes into the total of the ones. Then we have 2 tenths and 8 hundredths, representing that number. And now, we have to switch up our logic for the last one, just a little bit. So this number is 1, 2, 3, 4, 5, 6 numbers after the decimal point. So this is our tenths, as we know. Hundredths. And this place would be the thousandths. And this would be the 100,000s. And this would be the millionths. And this would be the 100 millionths. So, instead of using the 10 bundles for these over here, how we did before, we're just going to shift it to being here. So now if we say this 3, 4, 5, 6, 7, 8, 10 equals the millionths. So 1 bundle equals the millionths. So in order to get 3 of them, we have to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 bundle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 bundles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 bundles. So here we have 3 bundles of the millionths. And like the same logic of the hundredths, to get the 100 millionths, it would just be 2. So this number is 3,200 millionths. That is all for problem 2 of section 1.2.